Hi, this is Alex from devstories.eu. GeoDjango and PostGIS, Episode 4 of 15. Try measuring the footprint of a building using latitude and longitude, and your numbers will be completely useless. That is because latitude and longitude are just angles from the center of the Earth, not physical distances. To turn those angles into usable measurements like meters or feet, you need a coordinate reference system and an SRID. A coordinate like 48 degrees north and 2 degrees east is just a pair of raw numbers. Without context, your database does not know how to map those numbers to the physical world. That context comes from the Spatial Reference System Identifier, commonly called the SRID. An SRID is simply an integer that links your raw coordinate data to a specific mathematical model of the Earth. By default, GeoDjango geometry fields use an SRID of 4326. This integer represents the WGS84 coordinate system. It is the standard model used by GPS satellites and most web mapping libraries. It stores data using degrees of latitude and longitude. WGS84 is excellent for pinpointing locations anywhere on the globe. However, it is a geographic system, meaning it models the Earth as a three-dimensional shape. Here is the key insight. You cannot accurately calculate flat distances or areas using degrees. The physical distance between two lines of longitude shrinks as you move from the equator toward the poles. If you try to find all coffee shops within 500 meters of a point using SRID 4326, the database must perform heavy spherical math on the fly, which is slow and often imprecise. To solve this, you use projected coordinate systems. A projected system mathematically flattens a specific portion of the curved Earth onto a two-dimensional grid. Once the area is flattened, the coordinates change from angles to standard units of length, such as meters or feet. This makes distance calculations fast and accurate using basic geometry. Your choice of SRID depends entirely on the scope of your application. If you are building a global flight tracking system, you store your data using WGS84 and SRID 4326. Your points span the whole world, so you need a global system, even if distance calculations are slightly more complex. If you are building a local city planning application to measure exact property boundaries, using WGS84 is a mistake. Instead, you assign a local projected coordinate system to your spatial field. For instance, you might use a specific state plane coordinate system with its own unique SRID. These local systems are highly tailored. They minimize the distortion that happens when you flatten a sphere, but only for that specific geographic zone. When setting up your models in GeoDjango, you define the SRID directly on the spatial field. If you do nothing, it defaults to 4326. If you want a localized projection in meters, you pass that specific integer to the field definition. GeoDjango then treats all geometry in that column according to that specific mathematical model. The right SRID ensures your distance calculations do not warp as your data moves further from the equator. Thanks for tuning in. Until next time.